So we're going to look at solving equations in one variable, specifically rational equations, which is always your favorite thing to do. So our first goal is to, oh wow, look at that. Let me change this really quickly to something a lot more fun. There we go. Isn't that much more fun? In fact, I want to change it to this one. There. There's my lightsaber. All right, so we need to get rid of this fraction here. Look at all of your denominators. Whatever the least common denominator is, that's what you're going to multiply every single term by. So like this one's pretty simple. We only have an x, so I'm going to multiply this term by an x, this whole term by an x, and that term by an x. So we're going to do x times, and then times x over 1, and then this is times x. Bless you. And so when I multiply these two together, I get x squared. Well, that does not look very much like an x. Let's try again. So I get x squared. And then don't these cancel? The x's cancel on that one. And so I end up with a positive 3 equals 4x. Now that equation I can solve. How am I going to solve that? To solve an equation, what was that? Yes, but before I could, maybe quadratic formula, or I could factor. But right now, in the form that it's in, can I leave it this way? I have to have 0 on one side. Good. So I'm going to move the 4x to the left by subtracting it. So I get x squared minus 4x plus 3 equals 0. Then I have no coefficient from the squared term. I only have this constant. So what factors of 3, it's positive, add to give you 4? 3 and 1, right? So the x squared becomes x and x, and 3 and 1 multiply to give you 3, but they add to give you 4. My middle term is negative, so the 3 is the bigger of the two terms. It always carries the sign of that middle term. So if the 3 is negative, what does the 1 have to be to combine to make a negative 4? Negative also. And then this is equal to 0. Then to solve, we've got x minus 3 equals 0, and x minus 1 equals 0. You could have used a quadratic formula instead of factoring. If you are uncomfortable with factoring, use that quadratic formula. And so what does x equal? 3 and positive 1. We have to look for what are called extraneous solutions, if I can say that correctly today, extraneous solutions. An extraneous solution just means that I have these two solutions here. They may not always work. You have to go back in the original equation. Tell me in this equation where x is restricted. What can x not equal in the original equation? X cannot equal to 0. Is that one of my answers down here? Is that one of my answers here? Nope, so we're good to go. I don't have an answer of 0, so these are my solutions. What does that tell you about the graph of x plus 3 over x equals 4? What do the solutions tell you about that graph? Doesn't the graph cross the x-axis at 3 and at 1? That's what it's telling you. If you had an extraneous solution, it would not cross. So let's say that 1 was extraneous, for chuckle's sake. Your graph would not, we'd cross it out, we'd throw it out, and you should not see if you were to graph this. Well, in order to graph this, what would you have to do to it to put in your calculator? Can you put it into y equals like this? What do you have to have on one side? 0. You would have to subtract the 4 before you put in your calculator. But if you put this in your calculator, and if 1 had been an extraneous solution, you would not see the graph cross at 1. And the reason why I bring that up is because your Math Excel questions are going to ask you, they're going to show you a graph and say, out of these two zeros, which one or ones are extraneous? You have to look at the graph and estimate where it's crossing the x-axis and look to see, you know, which ones you might throw out. You might throw out both of them. You might throw out one of them or none of them. All right, look at B. What are we going to multiply every term by here? X minus 4. Now you do have 0 over here and you do have this fraction over here. You could move the 1 over x minus 4 to the right and create a proportion by putting x over 1 and you could cross multiply. The math is actually easier. Most of you won't think to do that, but I just thought I'd throw that in there. But we are going to multiply by x minus 4. So this x gets multiplied by x minus 4. This one gets multiplied by x minus 4 over 1. And even the 0 gets multiplied by x minus 4. So these x minus 4's cancel, and then I'm going to distribute the x here into the x minus 4. So I get x squared minus 4x. And then when these two cancel, what am I left with? 1. So I get a plus 1 equals 0. Are you able to factor? Are you able to come up with factors of 1 that add to give you 4? Nope. So that's not factorable, so instead we could use what? Quadratic equation. So what does A equal? What does A equal? 1. How about B? Negative 4. And how about C? Positive 1, right? And we're using ax squared plus bx plus c equals 0 to get those values. So the quadratic formula, x equals the opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2a. The opposite of b plus or minus the square root of b squared minus 4ac all over 2a. Catchy. Learn it. Then we're going to put our values in for a, b, and c. So b is negative 4, so it goes here and here. And a is 1, c is 1, a is 1. And we're just going to do the math. So we get positive 4 plus or minus the square root of negative 4 squared is 16. And then negative 4 times 1 is negative 4 all over 2. 4 plus or minus the square root of 12 all over 2. Doesn't 12 factor into 2 times 3? Can't I take out a pair of 2's out in front as a 2? So I end up with 4 plus or minus 2 radical 3 all over 2. And finally, you have to actually take this 2 and divide it into the 4 and into the 2 red 3. If it doesn't divide into both of these, you can't divide it out. So our final answer is 4 divided by 2 is 2, plus or minus 2 red 3 divided by 2 is just radical 3. In Math Excel, you're going to have to separate this into 2 plus radical 3 and 2 minus radical 3. And you're going to have to separate with commas. They're decimal equivalencies. If you were to punch it out on the calculator, this one would equal, let me move it to the right a smidgy. So this one would be approximately equal to 0.268. And this one would be approximately equal to 3.732. So you have to read the directions. Do they want you to have your answer in decimal form? They'll say round to the nearest hundredth or thousandth. Or they'll say give the exact answer. So this is the exact answer. This is the estimated answer. So you have to pay attention. Read everything. Underneath each of the answer blanks, they have things in blue that tell you how they want you to give the answer. Separate the answers with commas. That kind of thing. All right, if you're ever in doubt, look at view an example. All right, so any questions on those two? What is the restricted value for x in this problem? What can x not be? X cannot be what? 4. 4 was not one of our answers, right? So we don't have to worry about any extraneous values. So let's go ahead and look at example number 2. These ones do have extraneous solutions, and they're a little bit more complicated. As you look at your denominators, This is fully factored, isn't it? This is fully factored. Is this fully factored? Nope. So we're going to factor it. We're going to go ahead and factor it. The x squared becomes x and x. What factors of 3 add to give you 4? We just did this one, right? What factors of 3 add to give you 4? 3 and 1. The 4, the middle term is negative, so the 3 is bigger, so it gets the sign of the middle term. What does the 1 have to have? What's the 1 have to have? Also a negative. Isn't that a coinkydink? Aren't these the same? Aren't these the same? Our different factors are x minus 3 and x minus 1. In your LCD, you have to have at least one of each of the different factors. So this one actually has the LCD. So we're going to multiply every term by that long LCD. So this one gets multiplied by x minus 3. I'm going to try to squeeze that in, times x minus 1. This one gets multiplied by x minus 3 times x minus 1. And then this one gets multiplied by x minus 3 times x minus 1. And then we're going to cancel. So this x minus 1 cancels with that x minus 1. This x minus 3 cancels with this x minus 3. And then both of these cancel with both of those. So we are left with the following. For the first term, we have 2x times x minus 3. Plus, we have a 1, which I normally don't write, times an x minus 1 equals, then we just have a 2 left over. Are you writing with me?
Yeah.
Okay. Is everybody clear as to where I got those values? And now that we got rid of all the fractions, it should be fairly simple to solve. So we're going to go ahead and distribute the 2x into the parentheses. So we get 2x squared minus 6x. And then when we distribute the 1, don't we just get what's in parentheses? Plus x minus 1. And then I'm going to go ahead and subtract the 2 because I know I have to have one side equaling 0. Then all that's left is to collect like terms. So we've got 2x squared, a minus 6x, and a positive x gives me minus 5x. And then the minus 1 and the minus 2 gives me a minus 3 equals 0. So this is a harder one to factor. You could either use a quadratic formula or factor. So I'm going to take my bookends right here. And I'm going to take 2 times negative 3. What do I get? Negative 6. So I'm going to factor negative 6, and I'm looking for this middle term here of negative 5. So what factors of 6 subtract to give you 5? 1 and 6. So 1 and 6 subtract to give me 5. My 5 is negative. So I want the bigger of the two factors, in this case the 6, to carry that sign. So what does the 1 have to be? Positive or negative? Positive. So remember, I just created my two new middle terms. So that's a 1x and that's a negative 6x. We're going to replace this 5x right here with x, a positive x, and a negative 6x. The middle term gets replaced with those two new middle terms. Then bring down your bookends. Your bookends are 2x squared. Whoops. Oops. Oh, darn it. Okay, well, it's not going to fix itself now. So sad. 2x squared, and then a minus 3 equals 0. So for group and garbage, we're going to cut this in half. So there's your two groups. Get rid of the board. There you go. All right, so look at the first group. What's the GCF in the first group? X. So we've got x times, and we're going to divide each of these by x. What do I have left? 2x squared divided by x. 2x, and then plus 1. And then what's the GCF in the second group? Not just a 3. we want that third term to be positive. So we're going to factor out a -3, and we're going to divide each of these by -3. Anytime that third term is negative, you want to factor out a negative. And so we end up with 6x divided by a -6x divided by -3 is a positive 2x, and -3 divided by -3 is a positive 1, and that equals 0. Then don't they have a 2x plus 1 in common? So that 2x plus 1 comes out in front of parentheses, and what's left over, the x minus 3, goes inside parentheses. And then all that's left is to set those equal to 0. So 2x plus 1 is equal to 0. X minus 3 is equal to 0. Subtract 1, 2x is equal to -1. Divide by 2, x is equal to -1/2. Or x is equal to what? 3. We have to look at our extraneous solutions way up top. So go all the way back up top here to these three denominators. What can x not be? Let me find a, bless you, let me find a good color. Oh, purple's good. Love purple. So what can x not be? Here, 1. What about here? 3. So x cannot be 1 or 3. And same thing with this, x cannot be 3 or 1. So are any of my solutions 1 or 3? Yeah, so we're going to get rid of the 3. That's called extraneous. So this is an extraneous solution. When we multiply by that least common denominator, it affects things. And the equation doesn't understand that our denominator can't be 0. We have to be smarter than the equation. So we throw that out, and then our only solution is x is equal to -1/2. So what does that tell you about your solutions? What does that tell you about this solution here? It crosses the x-axis, this graph crosses the x-axis at -1/2. Is it going to cross the x-axis at 3? No. So if they gave you these two choices as solutions, you'd look at the graph and you go, okay, it's not crossing at 3, so that has to be extraneous, so you're going to cross that out. Because it depends on how they ask you some of those questions. Alright, so let's go ahead and look at B. I want you to decide in your table groups what is the least common denominator, and on top of that, you got to factor this denominator right here. So factor that denominator and find the LCD on your own. Well, in your table groups. You got 30 seconds. Talk, talk, talk. All right, so what do we come up with for a factoring for this one here? X squared plus 2x. How does that factor? X times x plus 2. Again, isn't that a coinkydink? We've got an x here and an x plus 2, so doesn't this have the LCD? All right, so we're going to multiply every term by the LCD. We're going to multiply this whole thing. Notice I'm putting in parentheses. So this whole thing gets multiplied by x times x plus 2. And then this one gets multiplied by x times x plus 2. And this whole thing gets multiplied by x times x plus 2. And then our x plus, or our x here cancels. So we are left with x minus 3 times x plus 2. And then on our next one, our x plus 2's cancel. So we're just left with a plus 3x. Oh, this is going to be really important. We need to change, because otherwise it's not going to work out so swell. We need to change, I forgot to tell you this. Change this problem here. Change the equal sign to a big plus. Change this to a big plus right here. And then change this to equal 0. Otherwise it's not going to work out. Are you with me? All right, so then when we multiply, we got our x cancels and our x plus 2 cancels, so we're left with a positive 6 equals 0. Then you have to FOIL this correctly, so we get x times x is x squared, x times 2 is positive 2x, negative 3 times x is negative 3x, and negative 3 times 2 is negative 6, plus the 3x, plus the 6 equals 0. Don't several things cancel out? So we're going to cancel out the negative 3x and the positive 3x. We're going to cancel out the negative 6 and the positive 6. And that leaves us with x squared plus 2x equals 0. How do we solve for that? What do you do first? It starts with an f.
Take out the x.
Which is factoring, right? So we're going to factor out an x out in front, and we're going to divide each of these by an x. So I get x plus 2 equals 0. So set the x equal to 0 and the x plus 2 equal to 0. So this is x equals 0 is one solution, and this one would be x equals negative 2. Let's look up and find our extraneous solutions. So let's look up here. Right here. We're going to see what can x not equal. X cannot equal what here? 0. And x cannot equal what here? Negative 2. And then the same thing here, x cannot equal 0 or negative 2. So are either one of these a solution? You have to throw both of them out. They both get tossed. What's left? Nothing, so it's no solution. So you have to be able to tell me that if nothing is left, that the answer is absolutely no solution. So don't forget to look for those extraneous solutions. Any questions?